Okay, so I want to use MATLAB now to teach you how to differentiate and integrate in MATLAB symbolically. Okay, so your calculator can find values at points. It can even do definite integrals and find areas under to a curve as decimal approximations using Riemann sums, but it will not do it using antiderivatives. Okay, so I want to go over how MATLAB is more powerful than your calculator. So we can do it this symbolically, okay? We can declare X to be a variable in the command window. You can also do this in scripting or coding, but we're just going to do all of this in the command window for right now. So we are going to declare X to be a symbolic variable. So if we type in sims X, it will make that a symbolic variable. All right. We could add other variables. We could have Y and Z as well. And you could add them all at the same time, but let's just do X. All right. And let's now declare f of X is the function X squared. I do not need to put the dot in, okay, because X represents all possible X's as opposed to a vector of X values. So there's no dot necessary. All right. And you can see now that I have f of X in there, I could say, well, what is f of 3? Sure enough, the answer comes out to be 9. By the way, if I do f of 3 with a semicolon, no answer is reflected back in the command window. All right. So if you want to see it in the command window, leave the semicolon off. If you don't want to see it in the command window, put the semicolon on. It suppresses the answer. Now, what I might want to do is find that, well, what is the derivative of f of X? Okay, so let me just do diff. That's for differentiate. F of X, comma X. Okay, that means differentiate f of X with respect to the variable X. Okay, that's like df dx. So the comma X is with respect to X. Sure enough, the answer is 2x. All right. Well, now what if I wanted the derivative to actually be stored as a function? Okay. Well, I could let d1 f of x. You want to put the f of x so it'll store it as a function of x equals diff of the differentiation of f of x with respect to x. Right? And now if I do that, it exists. So d1 f could be evaluated at a value like 3, because d1f is now a function that is in the memory. And sure enough, since the derivative of x squared is 2x, when I go to evaluate it at 3, the answer is equal to 6. Well, now let's try integrating. All I have to do is say int f of x, comma x, and it tells me that it's x cubed over 3, which is exactly what we would expect. Okay, now notice it doesn't put the plus c in. Okay, so it's giving me the simplest antiderivative, the one where c is 0. It doesn't put the plus c on. Okay, but it gives me a symbolic answer. It will give it to me at any values that I want. All right. Now, other things I could do, I can integrate f of x with respect to x on the interval from 0. Let's go up to 3. Right? And it gives me that the answer is 9. Okay, so it actually took the antiderivative at 3 and subtracted the antiderivative at 0. If we do int of f of x with respect to x from 1 to 3, it gives me a fraction answer, 26/3. So notice it didn't give me a decimal for that, which is what I would hope for. Okay, that's the exact answer, 26/3, as opposed to making that 8.6666 repeating. Okay, so that's symbolically exactly the right answer. And so that shows you how you can differentiate and integrate in MATLAB and get exact answers. So in your homework, you're going to have problems. Let's just do one more. Let's define like g of x equals cosine of x. All right, there we have it. And so let me integrate g of x with respect to x on the interval from 0 to pi over, let's go from 0 to pi over 3. Let's see what happens. Okay, so notice it gave us the 3 raised to the half is the square root of 3 over 2. Okay, that ends up being the area. Oh, well, why is that the case? Because if we integrate g of x with respect to x, we can see the antiderivative of was sine x. So if we take the sine of x at pi over 3 minus the sine of x at 0, we'll get the answer that we just had a moment ago. Okay, we could integrate g of x from 0 to pi. Let's see what happens. All right, and the answer is 0. Oh, because we have a positive bump of the cosine curve followed by or a quarter cycle that's positive and a quarter cycle that's negative. Therefore, we end up with a total area that's 0. Okay, so MATLAB will give us the exact answers, not just decimal approximations. So use this on your homework to check all of the even problems.